Assalamu alaikum. Hello guys, I'm Yasir and in this tutorial we'll discuss about load capacity of a coil tubing string. This topic is very important considering the job design and as well as the coil tubing job execution. So we'll see that how to measure the load capacity of a given coil tubing string, what is load capacity and what is its significance. So let's go to the computer screen and discuss this topic. So let's start our discussion with the definition of load capacity: the maximum pull weight which a given coil tubing string can hold before its failure is its load capacity. Simply, the maximum pull which a coil tubing can bear is its load capacity. Talking about the significance, as I mentioned earlier, that it is significant both during the designing phase and during the execution phase. During the designing phase, just assume that we are going to design a fishing job and the required force to remove that fish is 35,000 pounds, and at that particular depth, let's say we have to remove the fish from 10,000 feet, and at that particular depth, that's 10,000 feet, the coil tubing weight is 40,000 pound. So we need like 70,000 pounds force. We need a coil tubing which can hold the 70,000 pounds. So this particular knowledge is important before designing the job for that particular operation. Similarly, during the execution, operator need this value so that in case he gets stuck, he knows that how much extra pull, that is over pull, he can apply within limits of that CT string. So the knowledge of this load capacity, that is maximum pull, is important both during the designing phase and as well as during the execution phase. Now we'll see the factors affecting load capacity. The first factor is the material yield strength. Higher the material yield strength, the higher will be the load capacity. That is, if we have a coil tubing string with let's say 80,000 pounds and then other coil tubing with 90,000 pounds, so the coil tubing with the 90,000 pounds yield strength will be having the more load capacity. That is, it will have the more pull weight that we can apply. And of course, you know that this yield strength is actually is mentioned in the form of grade. When we say that GT 90, this 90 is basically the yield strength, 90,000 pounds. And then comes the wall thickness. Of course, greater the wall thickness, greater will be the pull capacity, greater will be the strength, greater will be the load capacity of the coil tubing string. And then the pipe outer diameter, that is OD of the pipe. So if the material yield strength and wall thickness is same and just we have the different outer diameter, then the coil tubing which have the more diameter, the bigger coil tubing will have the more pulling capacity. So all these three factors have the direct relation, that is, higher the yield strength, higher the pulling capacity, higher the wall thickness, higher the pulling capacity, higher the outer diameter, higher the pulling capacity. So these three factors have the direct relation with the load capacity or the pulling capacity of a coil tubing string. Now we'll see the formula to calculate the load capacity of the CT string. So load in pounds is equal to minimum yield strength in PSI into cross sectional area in square inches. It is simply the formula of the pressure which is rearranged, that is pressure is equal to force per unit area. So this is basically force or load, and this is the cross sectional area, and this is the basically the yield strength which have the unit of pressure, that is PSI. Now we'll perform the exercise with the help of this spreadsheet. So here we have this spreadsheet, load capacity of the coil tubing string. So the three factors, that is coil tubing OD, wall thickness and material yield strength, are the input parameters. Then the safety factor. Usually when we design a job, we consider some safety factor, that is, we just use the 80% or sometimes 70% depending upon the some other factors which we will discuss later. So here the OD is 1.75, wall thickness 0.175, and the yield strength is 90,000 pounds. and if we just use 20% safety factor, we will see the maximum tensile force or maximum the load we can apply to this coil tubing string is 62,000. Now we'll just change the diameter and we'll see the effect. So if we just all keep other parameters same, just increase the outer diameter, that is we make this diameter, let's say 2 inch, we'll see, we can see that this diameter has been increased from 62 to 72,000 pounds. If we go to 238, that's 2.375, we'll see that other parameters are still same, but we have the more load capacity. Now we will see the effect of, let's say, this wall thickness. Here we have 0.175. if we just reduce the wall thickness, let's say we go to 0.145, we'll see that its load capacity is 52,614. if we increase, let's say 0.190, and the tensile load has been increased from 62 to 67. Okay, now we'll see the effect of this yield strength. Let's say we have a coil tubing string with 70,000 pounds, so its load capacity is 48,000. Then if we have, let's say, 80,000 pounds, its load capacity is 55,000. If we have 90,000, it will be 62,313. Here in this picture we have the properties from the manufacturer. We'll just compare our formula. So here it is GT90, that is 90,000, coil tubing is of 2 inch, and the wall thickness 0.175. so if we just put the safety factor, let's say 100%, so we'll see that it is 90,255, and here we'll see that it is 90,300, almost same. So in this way we can calculate the load capacity of any coil tubing string whenever we need. So that was the discussion of load capacity. I hope that you got understanding regarding what we have discussed. So thank you very much. See you in the next tutorial.